My name is Cecilio Angulo. Okay. This is my profile on LinkedIn, so you can enter there and to check it. So my background is mainly mathematics and artificial intelligence, but my vocation is to work on social robots. And what I want to present to introduce today is a research that we were developing during the last 2 years with 2 more colleagues. That is about to work with robots in the industry domain. But because we are in the industry domain, it doesn't mean that we are working with industrial robots. Okay, so we are trying to move social robots, caring robots, assistive robots, I don't know what is the name that you prefer, to the industry, to the factory domain. Okay, so this is the main aim. The point is, because you are not at home, because you are not on the street, it doesn't mean that you can use social or cognitive robotics. And this research is mainly funded by 2 projects. One is AI for You, that is a project where we are working in collaborative human-centered AI. So this is coming from AI, but especially human-centered. This is the point. And the other project is one project that is also funded by the European Commission, but in the Catalonia region. And it's about the collaboration and the shared use of workspace by people and robots in factories. Okay, so we are mainly talking about cobots. Okay, so collaborative robots. And the people that is collaborating with me is Pere Ponsa and Alejandro Chacón. Okay. And this is the in short, this is the main concept that I want to introduce today. Okay, as I was telling you, this is a work from the last 2 years that we were collaborating on that. So we are not pretty sure about the sentences that I will affirm. Okay, so if you feel that some sentence you don't agree, you feel that something is wrong from your point of view, you feel, so please feel comfortable to introduce your concern and to discuss about it. Okay, so please, research means that, okay, means that you are making something that is more than innovative, and sometimes you are working in the wrong pathway. Okay, but we are trying to work in a robust sense. So in short, I want to introduce 3 concepts. The first one is about what it can mean caring robots in manufacturing. Okay, so yes, we are in one industrial setup, but we are not talking about industrial robots. The second point is how we can design one experience in this domain, because you will see that we are especially dedicated to the human. Okay, so the human is in the center of the research, and that means that you need to define your experience not from the product, not from the process, but from the human. And the third point is, in order to evaluate this interaction, this collaboration between human and robots, you can work in the cognitive side, you can work in the social side, you can work in the physical dimension, like in the previous presentation. In our case, we will work in the mental workload. Okay, and why the mental workload? Because we have some instruments from social science that we can apply in this new domain. Okay, this is the point why we are moving to this new topic and this new cognitive significance. So from the first point, okay, so the main aim is we are trying to move from machine-centered factories, okay, to factories where people is collaborating with machines. Okay, this is one typical example where you can observe where is the human, okay, and I don't know who is in the jail. Okay, is the human on the jail or are the robots into the jail? Okay, I don't know. That's the point. But this is the current, okay, the current state when people is talking about the industrial robot. But what we are trying to do is to move from this perspective to another perspective that is collaborating. Okay, the most common robot that people is using today, like a cobot, is the robot from Universal Robot. Okay, there are other robots from ABB, from KUKA, and so on. Okay, so it's not one commercial that. Okay, but this is the most popular robot. But if you are going to the Universal Robot webpage, okay, and you are checking the case histories, okay, here I am providing 3 links that you can go there and to check the videos. In all the cases, the perspective is similar to this one. So the human is in one side and the robot is in the other side. Yes, now there is not a jail, okay, there is not a cage. So they are sharing. They are sharing the space, but this is the only collaboration that they are using. Okay, and we were wondering why is happening that. Okay, this is our first wondering. The second one is if you check that, okay, and you are one small and medium company, okay, remember that in Europe, 80% of the companies are small and medium enterprises. Okay. I don't know you, but I cannot afford, okay, to buy all this quantity of robots. Okay, so why robots are not more present in small and medium companies is because people cannot afford this kind of robots. Okay, but they can this kind of robots. Okay, so the next point is let's try to help the small and medium companies that is around 80% of the economy in Europe to use these robots. Okay, this is the perspective. This is the motivation of the project. Okay, and in order to do that, our framework is what it is called Industry 4.0. Okay, but if you are checking Industry 4.0, okay, and you can go to Google and to check what is the common pyramid, okay, and it's something like this. So people is starting in the field level using sensors, then you have the machine control, okay, using the typical Siemens or Schneider or whatever elements. Then you have the SCADA for the process control. Then you have the MES for the production, and finally you have the planning using some kind of ERP. Managing your system. But this is a perspective from the process view. Okay, where is the human here? The human is a disturbance in this system. Okay, so the human here is some external element that is introducing noise in your system. But this is not the aim. Okay, we are not expecting that the humans are noise in our system. Okay, or the humans are the feeder to the machine. Okay, we are not expecting that. We are expecting that the humans can employ the skills that they have, and we have very good skills. Okay, so we need to work in this kind of pyramid. Okay, I need to invert. Okay, we need to invert this pyramid. And then this is the first approach that we were working on. That is, okay, in order to move to the human-centered approach, okay, the left triangle pyramid is from the cyber physical systems. Okay, so that means systems that are merging the physical aspect and the cyber aspect. So that means you have the cloud and you have the data and so on. Okay, so again you have the smart connection level, you have the data, you have the cyber level, you have the cognition level and the configuration. But we need to move to the cyber human systems. Okay, and in the cyber human systems, the smart connection is very low. Okay, in this case, in the case that I am working with, is the cognitive part. Okay, so the smart connection is not physical, it's not social, it's only cognitive in my sense. It's only the workload that you are employing when you are making your experience. And then you have the data. okay? But again, the human are able to process data, but not too much, okay? We are not one GPU, okay? So we can process the data, okay? We can process the data in a very high level of cognitions, okay? But not too much data, yes? And finally, the good point is that we are very, very flexible. Okay, so our main skill is that we can move from one position to another position in the workstations and to be very productive. Okay, so our approach is how we are able to merge these both worlds. Okay, the world that is coming from the cyber physical systems and the world that is coming from the cyber human systems. Okay, this is the question that we were posing 2 years ago. And the answer was similar to something like this, okay? So this is one approach that we were defending in this article, okay, with Alejandro and Pera, in order to develop cognitive advisors, okay, in Industry 4.0. Okay, so we are talking about what we are calling more people, okay, but we in general we are calling human cyber physical systems. So it's physical systems that are mixing the cyber part but also the human part. Okay, and then we have the operator. Okay, the operator, because it is very flexible. Normally, it is also called operator 4.0. Okay, again, this is only one name, okay? Don't worry about that. But that means that we are really, really interested on the skills that the operator can introduce into the system, okay? So the operator is here, is a part of the process, okay? The operator is a part of the process. And then our main interest is about the collaboration between the operator and the cobot, okay? This is what we are, for the moment, working on, okay? So we are working on that. But we were also realizing, okay, that, look, you are one operator, okay? And let's try to imagine that you are one operator with a certain level of expertise, okay? And then you are working with a cobot, okay? The cobot is connected to the cloud. So the cobot has a lot of information about the process. And that means that the cobot can inform you about how to modify how you are applying your skills, okay? So how to go speeding up or how to slow that or how to increase the level of quality because you are increasing the dexterous abilities from the operator, okay? But from the human perspective, the cobot for you is one training, is something, okay, it's not somebody, it's something that somebody was put in there in order to help you. So it's very, very strange that one training is telling you what to do when you are an expert in this process, okay? So in fact, what we need, okay, is to disassemble, okay, what we need is to disaggregate the physical behavior of the cobot, okay? So what the operator is watching from the physical process and the information that is coming from the process, okay? So from the process, from the ERP and the mesh, you are obtaining some information, but you need that the information is not coming from the cobot. You need that the information is coming from another entity. Okay, in this case, we were putting one physical entity. Okay, this is a now, but it can be any other kind of entity. Okay, but you need to disaggregate the physical part. Okay, the robot is there in order to help you. Okay, or the robot is there in order to collaborate with you. Okay, and when you are collaborating with somebody, you are not the how to say that, you are not working for the cobot. Okay? You are collaborating with the cobot. Yeah. So this is one social and cognitive significance. Okay, because the cobot it has the opportunity to send message to the operator. But this is not the good communication that we are expecting. Okay, we are expecting that the operator is really taking TruthNet from the embodied agent and not from the code. Okay, the code is only that in order to help you, in order to assist you. Okay, in this sense, the cobot is one assistive system. Okay, and the total system is taking care of you. Okay, because we are trying to take your best skills, and your best skills is to be flexible, to be cognitive. And that means that today you are in a certain workplace, and tomorrow you are in another workplace, and the other day you are in another workplace. Okay, and don't worry, if something is new for you and you don't understand that, there is a system that is helping you, that is taking care of you. Okay, this is the point. So what we are trying to do is before Guillem was talking about easy robots at home. Okay, what we are trying to do is to put easy robots in small and medium enterprises. Okay, we need that for the operator. The introduction of the robot is very simple, very easy, and obviously is helping the system to be more productive. Okay, this is the point. And another point that was also Guillem talking before is about the different robot roles. Okay, so the role of the robot like a master, the role of the robot like one trainee, the role of the robot like one co-worker. This is similar. Okay, so you need to manage that. Yeah, you need to manage how much information you are providing to your operator. So yes, we are in one industry domain. So it's not the usual home domain, or it's not the usual healthcare domain, but the kind of elements that we are working with are the same. Okay, in order that the process is productive, you need that the operator is inside the process, and the best, according to our perspective, the best form that the operator is inside the process is that the operator is into the center of the process. Okay, that is the point. Okay, so the question 2 years ago was how to link the best of both systems. Okay, from the operator point of view and from the robot or from the process point of view. And in order to do that, okay, we were trying to catch which are the best skills from both worlds. Okay, from the robotic world, okay, everybody is talking about the accuracy, about the precision, about the reliability, okay, about the force. That is nice. But then, from the operator is also introducing some interesting skills. The operator is flexible. The operator is very, very cognitive. The operator is dexterous. Okay, there are a lot of manipulations that you cannot do with a robot, but the operator is able to do that. Okay, but the worst part of the operator, okay, and why people is not using operators, or why people is not working with operators in some workstations, is about the human variability. Okay, so it's very clear that when the robot is making a process, is making a work, the robot is performing the task in the same form all the time in one very robust and reliable form. But this is not the case for the humans. Sometimes this is negative, okay? If you are only working, you are only thinking into the product, okay? And the product is something that is very precise. Maybe this is something that you want to avoid. So the human is noise. The human is a disturbance. Yes, the human is something that you must replace, okay? This is the fear that the people is having. But our point of view is different, okay? Our point of view is, in this moment, there are a lot of small and medium companies that they are not introducing robots because they don't know how to combine both worlds. Okay? Try to imagine, okay, I will put some examples, okay, but try to imagine that you have your process that is very precise and very concrete. But suddenly, there is a part that is different. It's not round, it's a square. Or it's not metal, it's wood. Or it's not black, it's white. Or it's not, okay? In order that everything is working, you modify your process. You need to put a new sensor, you need to code, you need to test that is working. But the next customer is asking not for wood, is asking for plastic. And the next one is asking not for red, is asking for green, or is asking for yellow. And the next one is asking for not round, is one hexagon. And so it's impossible to have so many sensors into your system. It has no sense. Okay? But the customer, you want the kind of part, you want the kind of product that you are asking for. And how to obtain that is by mixing the standard process, okay, with the flexibility of the humans. Okay, and we are trying to work on that. This is one point. Okay, so the topic that we try to work is with human variability. Okay, and the other point, what is complicated to do when you are working in social behavior is how to make measurements. Okay, to measure. To get instruments in order to measure that, okay? So I remember again, Guillem, that was telling you, okay, fortunately, we have another team in the UB that they are from social science and they have a lot of instruments. This is very important, okay? And in order to measure this human variability, okay, and in order to measure how this human variability is affecting the system, we are working with mental workload. Okay, mental workload is not the same that cognition, okay, but it's very related. Okay, and why we are not really working with cognition is because we have a very good instrument, that is the NASA TeleX instruments, in order to measure mental workload. Okay, and for the moment, we don't have very good instruments in order to measure cognition. Okay, and for this reason, we were derivating from cognition to this mental workload. Okay? They are very related, but be careful, they are not the same. Okay? So this is the first message. Okay? The first message is we want to talk about caring robots or caring processes in manufacturing. Okay? And why caring? Because we are taking care of the operator. Okay, we want to help the operator, to make easy the life of the operator. Okay, obviously with a very effective output. Okay, with a product that is in a very good quality and a very good quantity. Okay, we are expecting that. Okay, this is the first. The second message is about designing the experience. Okay, finally, we are talking about humans. So if we are talking about humans, that means that we are defining one experience that is involving humans. So I need to define everything, okay? I need to define how is the setup. I need to define what are the elements that are working there. I need to define the procedures and so on, okay? In this case, we are working with two working areas, okay? We have the working area one, that is this one, and the working area two, that is this area, okay? In the working area one, the human is performing one regular task, okay? And one regular task for one human is one task that is cognitive, okay? So the hypothesis is repetitive task is for robots and cognitive task is for humans. So in this case, to solve this Tower of Hanoi, okay, this is a popular example when you are working with cognitive problems. Okay, so in this case, the human normally is working with the Tower of Hanoi with 5 disks. Okay, and in the middle, there is a robot that is assembling this product that is composed by a base, the bearing, okay, that is rolling, and the cap. Okay, and in this case, the cap is having some letters, and you don't have a sensor to determine if the letters are on the left or the right or whatever. Okay, so you need that the human is going there to put the cap, to check that the letters are in the right form, and then to continue. Okay, so the only task for the human is the robot is making, is putting the base, is putting the bearing 4 times. Okay, this is one example. And then is asking for help to the human. Hey, I need your help. And then the human is going there, is putting the different caps, checking that everything is okay. And then the robot is moving the elements to the output part. Okay? And what we want to measure, okay, what we want to show is that when the human is only performing this task, you are able to perform any times this task. Okay, during 15 minutes, you are able to perform n times this task. When the human is disturbed by the robot, because the human must to check this part, okay, so to put the caps and to check the quality, obviously you will reduce the quantity of times that you are ending this task. But in the other side, now you have another product that you can deliver to your customer that in other case it was impossible because you don't have a sensor to determine where is the letter. Okay, so the point is you have 2 possibilities. The first one is to endow the robot with more sensors and to change the code and to modify everything. The other point is, no, I will ask for help for the human, and the human will help me. Okay? And what we want is we can understand that the number of times that you are ending this Tower of Hanoi will be less than previously. But what is important is that the human is not disturbed so much. Okay, so the human is able to perform this task, but also this task. And for this reason, we are measuring the workload for the human. Okay, so that's the point. Previously, the human is working in a task that is very, very cognitive. Then, in the next step, the human is performing one task that is cognitive and another task that is cognitive but more physical. Yes, not too much physical, but also physical. Yes, and the good point is that if you don't have one operator that is helping the robot here, you can never give to your customer the product with the quality that they want. Okay, because you don't know where is the letter. Okay, that's the point. But we need to design this experience, okay? And in order to design this experience, as Guillem was explaining before, we need to define, or we need to be sure that the experience is usable. Okay, if your experience is very complicated and the human cannot understand that, then the conclusions that you can take from your experience has no sense. So the first point is that your experience must be very well designed. From our point of view, is our experience is usable. And in order to do that, you need to define which are the participant selection criteria. You need to define which is the consent form. You need to define the case study. You need to define some demonstrations for the human. And finally, okay, you must have this ethics report, okay, from your institutional review board, okay, from the ethics committee. And obviously, you must share your data with all the community. Okay, so what we are doing is to sharing this information with all the people. Okay. In order to determine that the system is usable, okay, look, we are not working on the experience, okay? We are only working on the design of the experience. That is different. Okay? Our hypothesis is that the experience is usable. Okay? So the user, the operator, feel comfortable in this setup, in this domain. And in order to do that, we need, something is usable in the case that is effective, that is efficient, that has the satisfaction from the user, and you are not reducing too much the performance. Okay, so you are modifying the setup, you are introducing something, but you are not reducing the performance. And for all of these elements that are concepts, you need to determine some measures. Okay, for effectiveness, we were using the task completion rate. Okay, so how many times you are completing the task. For efficiency, we were measuring the time in order to complete the task. So not how many times, but how much time you are using for the task. For the user satisfaction, we will be using one questionnaire. And for the performance, we will use some key performance indexes. Okay? For the task completion rate, we will measure the number of moves that you are performing in the Tower of Hanoi and the number of cycles that you are performing with the robot. For the efficiency, we will use the time to task and the cycle time. Okay? That means this is one indirect measure about how much time the robot is stopped. Okay? Because it's waiting for the human. For the user satisfaction, we will use SUS, okay, that is a very, very popular questionnaire. And for the performance, again, we will use the wait time for the robot and the cycle time, okay? So how much time the robot is taking in order to perform the cycle. Yeah? So for the efficiency, we were expecting that you are measuring the maximum number of replays of Tower Hanoi in 15 minutes, okay, and at least 7 work cycles in the robot. For the SUS, okay, we were working in one particular range that you can go to the article, or you can go to the literature and you will see, okay, don't worry. And for the final elements, we have the wait time and the cycle time. And using these two measures, then we can calculate the per utilization and the per efficiency. Okay, the percentage of utilization of the robot and the percentage of the efficiency of the robot. Okay, so these KPIs are referred to the cobots. Okay, and the results. The results are, look, the humans are effective. So most of them are able to complete the task, okay? And there is a magic number that is 56%. So if your number is higher than 56%, that means that your system is effective. The system is efficient, okay? Why that? Look, this is the variability. Okay, sorry. This is the variability introduced by the robot. Okay, so the different time that the robot is taking in order to perform the task alone. Okay, and the variability is very low. It's 2.7%. Okay, it's a very low variability. Obviously, when we are talking about the human, the variability that the human is introducing is high, is 25%. Okay, so yes, the human is introducing variability. But when we are considering all together, okay, when we are considering the sum of the time from the robot plus the sum of the time from the human, the variability is only 4%. Okay, so it's not in the middle. It's not a number between 2 and 25. is only 4. Okay, and this is important. That means that it's true when you are using humans. Okay, when you are using humans, the time to complete the task is more time, but it's not so variable. You can more or less measure how much time you are using in order to do that. Okay? This is important. Okay, so the human is a disturbance, but not too much. It's not a noise. Okay. From the user satisfaction, okay, we were using the SUS for the hardware benchmark because it's the one that is the nearest one to our case. And according to the users, the system or the setup is excellent, so it can be acceptable. Okay, and this is the different dimensions that you are measuring when you are considering the user satisfaction. Okay, is how complex is the problem, how easy to use is the system, if you need support or you don't need support, how is well integrated, if the system is consistent or inconsistent, if that is quick to learn or everything. Yes. So this is all the different dimensions that we are measuring using SUS. Okay? And you can see that the measure is okay. And finally, we have the performance. Okay. Obviously, when we are using humans, we are increasing the time. So the performance will be not 100%. Okay. So in the case that the robot is able to perform the task completely alone, that means the performance is 100%. In the case that you need the help of the human, then you will have 2%. The first percentage is about the utilization of the participant. Okay, so how much time you are using, okay, the participant, and it's 83%. So the idle time, the static time is not so much. And the other one is the percentage of efficiency, okay, according to the cycle time. And you can see that obviously now is not 100%, but it's more than 84%. Okay, so we are discovering that in this case, our experience is, okay, when you are introducing humans, you are increasing the variability. Yes, that's true. When you are introducing humans, you are reducing the performance. Yes, that is true. But this is the quantity, so it's not too much. And the other point is now you have a customer that you can deliver a different product. In the other case, you need to modify all your system in order to do this task. Okay? So finally, it's the company that must determine the balance between one point and the other point. Okay? So the setup is okay. But remember, this is okay from the productivity point of view. But we are not so interested in the productivity point of view. We are interested in the workload. Okay? And in order to measure the workload, we need a different instrument. And this different instrument is called NASA Telix. Okay? So the work area, okay, you can see that is the one that is depicted here. Okay, this is the interaction between human and robot. Okay, you can see that the robot is really interacting with the human. Okay, it's not the human in one side and the robot in the other side. They are interacting in a shared space. Okay, this is the different tasks that is performing the human and the tasks that are performing the cobot. Okay, so they are mixing the tasks. And in order to measure this workload, okay, we have two different scenarios. The first scenario is the human is only working in the Tower of Hanoi problem. And in the second scenario, okay, the human is also attending, okay, this another task. Okay, so the robot was put in the base was putting the bearing, and now is asking that the human is putting the cap in these elements. Okay? Our hypothesis is that the mental workload that the human is using when it's performing only the Tower of Hanoi is increased when the human is performing the Tower of Hanoi 5 plus the collaborative assembly, but not too much. Okay, so what we want to measure is this delta. Okay, and in order to measure this delta, we are using the NASA TELIX index, that this index is using all these kind of subscales. Okay, and this is the paper, obviously, okay, is longer, okay, but this is the summary, okay. The summary is the blue is only when you are performing the first task, and the green is when you are performing both tasks. And this is the opinion from the human, okay. And the opinion from the human look that, and this is interesting, okay, this is interesting. The mental workload when the human was performing only Tower Hanoi is higher. Okay, the appreciation, okay, the impression, the subjective impression that the human has when it's performing Tower Hanoi is higher than when it's performing both Tower Hanoi plus collaborative assembly. And this is because two reasons, okay? The first one is the human was ever starting with Tower of Hanoi, only Tower of Hanoi. So the next time the human has some expertness about that. And the other point, when you were asking the people, is to perform the assembly is like a brick, okay? So you are not all the time making Tower of Hanoi, okay? You are not all the time working on that, but to work on the robot means that you are making a brick. And if this brick is not too fast, okay, but is paced, okay, is in a frequency that is good enough, this is like a form to free the cognitive, the mental workload for the operator. Okay, so according to the operators, to perform this another task is better than not to perform this another task, because it gives one opportunity to free your mind from the Tower of Hanoi. Okay, and this is very, very interesting. And also look about the frustration. Okay, so when the people was making only Tower of Hanoi, they were more frustrated than when they are performing both tasks. Okay, and they feel that the performance now is better. Okay, there is not too much difference for the physical part, there is not too much difference for the temporal part, and there is not too much physical for the effort. So to introduce this new task is really reducing the quantity of product that you are making. Okay, but for the human, it's not a plus, it's a minus. Okay, so what is surprising is that you are reducing the mental workload. Okay, the subjective mental workload. Okay, and this is interesting. Okay, so what you are doing is not to put more work, but to free the mind of the user, of the operator, when it's working in a task that is cognitive. Okay, and that's all. Okay, so in short, remember I was trying to introduce three concepts. The first one is in manufacturing, you can also work with social robots, with caring robots, with assistive robots. The second one, when you are working with humans, it's very important to design the experience. And the third point is to increase the number of tasks for one operator. It doesn't mean to increase the mental workload. Okay, in some cases, like in this case, the subjective opinion is that the mental workload is reduced because they have free time to make a physical activity, and this is important. Okay, so you are not how to say that is you are not putting more work, not real work on the operator, but you are helping the operator to be free mentally. Okay, and that's all. Okay, as I was telling you, there are many hypotheses in the middle. Okay, so the instruments, they were some adaptation from human-machine interaction to human-robot interaction, and sometimes it's complicated. Okay, because you need to change the questions, you need to change some orders and so on. So it's some starting results, but they are good enough. And I don't know, you have any question, any comment in the audience?
They can. Is there any question? You can open your microphone if you want to share with us your comments or by the chat. Don't hesitate to do.
Hi, Cecilio, can you hear me?
Yeah, we can.
Yes, there's one question. You measure the human feedback based on questionnaire survey.
Yeah.
Yes. Why not measure it like during the interaction with camera or with heart rate sensor? Is that any way to do that, or?
Yeah, it is possible. We have a camera, in fact, okay, and we were using the camera in order to measure the time that the operator is taking when it's moving from one workstation to the other workstation, okay? But we don't rely too much on cameras, okay? When you are asking for satisfaction, okay, we are not expecting that one operator is smiling when you are working, okay? And what we are expecting is the operator is neutral most of time. So yes, we can analyze the videos. We can do that. But from social science, SUS is one survey that everybody is agree that is working well. So we were using it. But yes, we can use videos. Yes, we can do it. But in any case, this measure is not more objective than a questionnaire, okay? Because you are interpreting what you are watching in the video. And sometimes it's not so easy to interpret it, okay? People that are working with micro behaviors, they are not, so from social science, it's not very clear that micro behaviors indicates the real behavior or the real feeling of the human. Okay, and this is also important. Okay, so videos is okay, but be careful about what you are analyzing from the video.
Yeah, this, so how about the heart rate or blood pressure? Some indications of the stress level.
Yeah, we can do that. We can work on it. The problem is that then you are putting more apparatus on the human, and that means that you need a time before the human is used to these different elements that the human is wearing. So the interaction is more complicated. Okay, and in fact, for maybe it's more precise your measure, okay, but for the measurement that we were making, it has no sense to put this pressure on the operator from one ethical point of view. Okay, so yes, maybe the result is not 86, it's 83 or 85, but in any case, it's more than 56. So the question is, has it sense to increase the pressure on the operator only because you are able to measure with this accuracy, this level of whatever? This is the question. Is it ethical to do that? Because we are not on the limit, okay? We are not in the boundary. This is not the case.
Yeah, thank you. I just thinking that there's a company like Amazon. I think they already did the test with the persons with a card and measure the blood pressure or I think the heart rate already. But I didn't. Yeah, they are industrial, so I didn't see any result from that.
Yeah, but in car driving is different because you are considering that there will be one accident.
Oops.
Maybe it.
Sorry, Cecilio, we are losing you.
Oops.
Yeah.
Now?
Now, yeah.
Okay, sorry. So the point is that when you are working with in cars like Amazon, okay, what you are having in mind is that you are trying to avoid one accident. So what you are trying to avoid is really something that is interesting. So it has sense from one ethics point of view that the human is wearing these kind of instruments. But in our case, this is not the point. Okay, the point is about the satisfaction of with the setup. So we were considering it because we have the sensor for that, but we were skipping it because it had no sense. More questions?
Not from my side anymore.
No?
Yeah, it's very clear. I just think of that. Thanks.
Okay.
Thanks.
And again, remember that this is only one position. Okay, so you can have a different position and a different approach, and this approach can be perfectly correct. Okay, so we are making research.